Hello, everyone. So I'm Falek. You've probably just listening a little bit about my career history there. Um, so I'm going to spend the next hopefully 50 minutes talking to you about deploying Synapse through Terraform and DevOps. So I am a principal consultant at Advancing Analytics. Got various certifications, but the key thing I enjoy is automating. And over the years, I've had to do a lot of deployment of infrastructure, and through that, it can become very time consuming. When you do things manually, it's really time consuming. It's difficult to repeat those steps as well, unless you've written them down and got really good instructions. You always forget something, and especially if you're doing something that someone else has deployed, they've probably missed something, or they've done something that it's in their memory, and that makes it really difficult when you're trying to deploy a cloud infrastructure. Also, it makes it difficult to have a consistent environment throughout. So if you've got your dev environment, which has 5 resources, but your production has 10, how are you going to be able to do the testing and checking for bugs and stuff if they're inconsistent all the time? So a little while ago, a couple of years ago, infrastructure as code came along, and that helped to mitigate some of these issues. Meant that you could write up a configuration script, which will then be able to generate the infrastructure based on that. Now, that reduced the need of having multiple scripting languages. So having things like PowerShell, as well as Azure CLI or REST API calls, having loads of different languages all in one, it kind of reduced the purpose of those. So you could configure everything in one place. Now, in this session, I'm going to run through what is infrastructure as code. I'm also going to go into one of the infrastructure as code tools, Terraform. We'll look at how to deploy a Synapse Workspace using Terraform, and also look at how we can publish that using CI/CD tools. So firstly, what is infrastructure as code? So infrastructure code is a way to automate your cloud deployment. Now, it's a quick and efficient way to update or destroy or change something, or create something in your cloud infrastructure. It's also a way that you are able to version control that infrastructure that you've deployed. You can share the infrastructure. So if you've got a configuration file and you want your another team wants to use it, you can basically share that. You can also reuse them for different environments. So if you've got one file, you can reuse that for your dev, test, and prod. It's this configuration file that I keep mentioning. It's effectively a blueprint. So just like you have a blueprint for a house, you've got a blueprint to say, this is the specific things I want you to build, and these are the configurations I want you to ensure that you consider when you're building your infrastructure. Now, there are various tools out in the market. So there's ARM templates that everyone is probably familiar with. And then you've got Bicep, you've got Terraform, Pulumi, and then there are also other cloud providers that have things like CloudFormation and Google's version of Deployment Manager. So we're focusing on Terraform. And the key reason Terraform is built by HashiCorp, the key reason is cloud agnostic. So what that means is you can use it with various other cloud service providers like Azure, AWS, and Google. And there's a couple of benefits to that. One, a lot of your clients are going to probably, or customers or organizations are going to want to not put all their eggs in one basket. So they have the ability to switch providers if they wish. And the other is that as a developer, as a cloud engineer, it helps our skills. So we have a skill set of Terraform that can be used in multiple providers. So we're not fixed to just Microsoft. We can also use that same Terraform skills in AWS. With Terraform, the syntax of how you execute it is always going to be the same, but the configurations for the resources will be different because they're all different in each cloud service provider. It's also open source, so it's free to use from the start. So you can download the CLI and you can get going by running it. There are paid versions, which is for the cloud, and then enterprise versions, and they give you additional features like security, logging, and a few other things. But there are also stuff that you can do within the, for example, Azure stack or AWS stack. So Terraform, the purpose of it is to help you provision and manage and version control your infrastructure. So it's doing exactly what we need, and it's going to allow you to deploy the infrastructure quickly and efficiently. It also allows you to be consistent. So you can use that same configuration file for multiple environments. So you can have a dev and test and prod all going from one core configuration file based on maybe slightly different settings, but it will always be deploying. If you wanted 10 resources in all the environments, you'll have 10, but each of the variables within that, you might set it up slightly differently. So it's also consistent whenever you run it. So every time you execute Terraform, it will always give you the same state. And the reason it would do that is it's basically captures a state file, which is a snapshot of what's been deployed. And then it compares the state file to your configuration file, and it basically determines what's changed. So no matter how many times you run that Terraform code, it's not going to delete all of the infrastructure that's already built. It will see that actually they've already built 8 of the 10 resources, so I only need to build 2. And that's what it's going to do. So it's going to always keep that consistency. Mentioned it's reusable, so you can use that one single configuration file that is your template, and then you can basically then deploy all the other environments, and that could be different environments as well as for different departments, your actual infrastructure. So you could ensure that all your departments have the same resources with the similar configuration. So you don't want your data science team having big clusters. You want to make sure that they're restricted to a certain size cluster. And you can do all of that and keep it reusable and keep it consistent. So there are some features with Terraform just to kind of go into. Is the first one is the resource graph. So what this means is Terraform has the ability to deploy resources in parallel for non-dependent resources. So this is basically if they're not dependent on each other, so something like a data lake and a key vault, they're not depending on each other, so it will basically can deploy them in parallel. Now, if this was done manually, you'd have to do one after another because you'll have to manually kick them off. But here, Terraform will identify that there's no dependencies, let's just run them both together. And that's great. Terraform identifies all of those dependencies. You can also explicitly tell it when to run things. So you can give it explicit dependencies. You can say, actually, I want you to run my key vault first because I need to get information for the data lake. And you can do that. You can explicitly tell it that you want to build those dependencies in. You've also got an execution plan. So each time Terraform runs, you basically generates an execution plan. And that execution plan is going to tell you what it's about to do. It's going to tell you if it's going to delete something, if it's going to add something, if it's going to update something. And it's just a plan. It's just a spectacle plan. It's not doing anything yet. It's just saying, this is what I'm about to do based on what I've identified. Terraform is all written in declarative configuration. Declarative language, so basically means it's very clear, it's explicit, it's because it's clear and very easy to read, is less chances of getting misconfigurations done on it. The language itself is HCL, which is HashiCorp Terraform HashiCorp configuration language. And it's quite a powerful language because it supports things like dynamic blocks, local variables, also handles complex data structures like maps and collections. And why is it beneficial? So if you've got like a VM, for example, and you have multiple VMs being generated and you want to loop through it and configure something, you can do that. And that's what's great about using the Terraform language. Now, if you choose not to use Terraform, it does just support this standard JSON, but you lose all of the benefits that you would get with HCL. So I mentioned the configuration file, and that's the first steps. That's what you have to do. You need that, and that's going to capture all your resources that you want to deploy, the providers you want to use, the variables you want to receive, and any outputs you want to display. And once you've done that, you basically then run the Terraform commands. And the Terraform commands, the core ones are init, validate, plan, apply, and destroy. And they all do different things, so different actions. So the first one will be init. So the first thing you do is Terraform init, and that basically initializes your project. And what that is doing is going and getting all the plugins, any modules from the Terraform site to basically so you can interact with your cloud providers and SaaS providers, as well as any other APIs you've got. And this is required. This is a must. Without this, Terraform won't work. And there are various providers out there. So you've got your official providers, which is managed and maintained by HashiCorp, and they tend to be your cloud providers. So they tend to be your cloud service providers like AWS and Google and Azure. And then you've got your verified providers at the bottom there. And the verified providers are things like Databricks, GitHub, and a few others. And they are managed by those third-party companies, and they're managed and built by them directly. And then lastly, you have a community providers, which is basically where the Terraform community will add their own providers, APIs, and so on. It's very similar to PowerShell Gallery. So if anyone's used that, it's a very similar concept to that. Once you've identified what you want, you need to put it into a Terraform block within your configuration. And the Terraform block requires to have the source of what it's doing. So if it's Azure or if it's AWS, and then the version, and you can change that version, and you can have it between a version, you can have it up to a version, you can say it's greater than a version. So there's various things you can do. You can have multiple providers as well if you want to use multiple, so say an official provider as well as a verified provider. And then you've also got then the configuration at the bottom of how you want it to connect. Do you want to connect as me? Do you want to connect it as a service principal? And that's where you use the provider block at the bottom. And then you have plan. And plan is doing that, looking at your state file, comparing it to your infrastructure, comparing it to the configuration file, and it's going to come back with a suggestion. It's going to say, this is what I'm going to do based on what I've identified on your configuration and on your state file, and it will generate your plan. If a state file doesn't exist, it will generate one. It will generate a blank state file just so it can come back with all of it needs to be built. Before it does all of this, it also does a validation of your configuration file. So it makes sure that your syntax and your arguments are all up to date and there's no errors. And that step is also can be done on its own. The state file itself automatically is by default stored on your local machine, which is all right if you're the sole developer, but not really great for collaboration, and not great if you're in a larger organization where you might want to update it later, because what if that person leaves and the laptop gets cleared? So it's not great for all of that. So your best practice is to store it in a remote location. And that remote location can be a blob storage account or a S3 bucket. And that's great because then everyone can then go to pull it down later, the latest version, and then publish it. And also when someone's using that file, it locks it. That means that there won't be multiple people trying to deploy into the same infrastructure or trying to deploy or update the same infrastructure for you. And then lastly, you then do a Terraform Apply. And Terraform Apply will again go and do a comparison, make sure that it's got the plan. It will generate a plan, so it will check the state file. It will then also look at what's already been deployed, and then at the end of it, it will give you a prompt to say, do you want to continue? Do you want to approve? And do you want to now deploy this infrastructure? And at that point is when you say yes, and then it's deployed. Okay. So next, we'll go into a demo. Before we do that, I'll just give you a high-level view of what is Synapse. It is going to be high level, so if you want more information, you can contact me afterwards. So Synapse is a unified analytical platform. It's there to help you ingest, do some data warehousing, do some analytical analytics. It's all basically about building and maintaining a solution within one application. So it's basically packaged up everything. It allows you to prepare the data by using Spark or SQL, so you can write queries in them. It handles serverless and dedicated pools. It ingests again data using hybrid methods. So you could use the code-free data flows. You could write SQL. You could write Spark. It also allows you to query the log analytics using KQL. It allows you to build orchestration pipelines. So build data pipelines that will move data from A to B. It can be, excuse me, it can be simple copy activities. It could be notebooks. It could be jobs. It could be stored procs. It could also just be a standard SQL. So this is just all about moving the data from one location to another. And then you can also explore the data that's in your structured or unstructured sources. So it can be in Data Lake or it can be in your SQL, and it gives you the Data Explorer that allows you to explore what's inside those storages. Synapse has its own method of role-based security, and it's basically you have a workspace access control. So you have to have access to the resource, and that lets you into the workspace, but it doesn't give you the ability to see anything in the workspace. So you can't see the SQL pools, you can't see the Spark pools, or you can't, or the queries or anything like that. You have to then give it explicit permissions within the workspace. So within the workspace, you give it permissions to say, I want this person to have access as a Synapse administrator or a SQL administrator or a Spark administrator, and it will give them access to those specific things. So it controls access in a slightly different way to any of the other applications. And then lastly, it's also compatible with Git, so you have the ability to publish it and use some of the CI/CD tools. So the demo that I'm going to run through will basically, we'll look at creating a resource group. Within that resource group, we'll then generate a data lake, and we'll have a container and a file system. And the file system is required because Synapse needs a file system, otherwise it doesn't work. And then we'll also look at Synapse, and we'll build a workspace, and then we'll start configuring that workspace. So then we'll do some firewalls, we'll add some roles, we'll link a data lake, we'll create a link service to a data lake that we've generated in the step before, and then we'll also do some of the permissions. And then we'll build a Spark pool, and we'll run some of the Terraform commands. We'll have some variables with outputs, and I'll run into them a bit more, and then we'll execute. So we're gonna basically configure the storage accounts. So we'll create the storage accounts and the workspace, and then we'll configure them. And that's the beauty of it. We don't need to then do this all manually for each time. So I'm just gonna take a drink. Okay, so this is the Terraform project we're looking at, is Terraform Synapse demo, and we've got two files in here to start with. So we've got a main and then just a PowerShell script, and that's just got some helper scripts in there. So we're going to look at the main, and the main is the core file that we're going to use. And before I go into the syntax, it's worth mentioning that Terraform have this website called Terraform Registry. And it's a really good place to start because it contains all the codes, all of the modules that you could possibly want for the provider that you're looking to do. So it will also give you the latest provider, so you can make sure you're staying on top. And it'll tell you how to write that bit of configuration. It'll also be able to tell you how, if you want to start with deploying the workspace, how you would do that. So it tells you this is what you need. So you could take this bit of code and you can actually go and run it. You might need to make a few tweaks to make sure it's fit to your needs, and you can actually run it, and you can start basically deploying a workspace. And you're not starting from scratch. It basically it speeds up your development. So that's what effectively we've done here, is we've taken the provider. So the first section is the provider, put it into a block, define which version I want, and then this description. Now Terraform gets updated on a regular basis. I think it's meant to be a monthly update, so it does get up to date on a very, very regular basis. But you can still use the previous versions. You just have to be careful of when they what their kind of lifespan is on them. So once we've got the provider, I've defined what subscription ID I want. And I've specified this specifically because I have multiple subscriptions, so I want this specific one. Okay, otherwise it can just use the stuff that when I'm logged in. Next, we've got is data sources. So data sources gives you the ability to go and get pre-existing resources that have been deployed in your cloud infrastructure, and that could be done by your cloud team. That could have been done through Terraform or not through Terraform, and it's the ability to go and get that information, get some of the properties for that. So an example is a virtual machine, virtual network. So you've got virtual network, and inside your virtual network, you've got subnets, and you need to put something in that subnet. So you need the subnet ID. Now, you could manually ask for someone to give that to you, but you could use the data call to go and get that ID and then use it in your Terraform project. So here, what I'm doing is I'm going to get the configuration, the client configuration, which is the client that's logged in, which will be me. And from that as well, it's going to get the subscription information as well. So that's what I want it to get. Based on what's logged in, I want you to get that. So that could have been me, or if I was logged in as a CLI, it would be that.
Quick one, just a second.
Yep.
I don't know if it's just for me, but I don't seem to be seeing your content. I'm seeing your desktop. I'm assuming you're sharing some information on screen. Maybe I'm wrong here. If anybody in the chat can say, can you see? So somebody saying correct. I hope that means I'm correct and that I can't see things.
Oh. Can you see
there
now?
We go. Now we can see Azure, and now we can see the Visual Studio Code. Yes.
Okay. Sorry, I switched screens, so
yeah, no worries.
I changed the duplication, so it may have been that. Okay, I'll go back to the beginning a little bit. So this was, I won't go back into it too much detail, but that was the provider. So here we've got the provider. There's my subscription ID. This is the data call to be able to get my get my credentials that of the person that's logged in into this application, into my local system. And then we got input variables. So input variables is variables you want the user to be putting into your project. So it's a great option to have. So you can basically then have multiple different variables being pushed in. So I've got region there. So this project for now might be on the UK South, but my next project might be a different region. So then I would want a different value put in, but then I don't have to go and change all of my project. I just have to change it in one location. Now, I've put defaults in these. So these blocks are really simple. All you need is a description, but I've also put defaults in them. That the defaults isn't good practice because you'll never find an issue if you've not passed the variables. So these variables are passed at the time of execution. So when we do the Terraform apply, that's when we provide them. And for the purpose of demo, I've put them as defaults, but I will remove them for the second half of the demo. And then we've got prefix, so we can reuse the prefix for when we create the names of our resources, and we can ensure that we've got a good naming convention, that the project name is in our name of our resource. So that's why we've built out a prefix and we've called it Synapse Demo. And then we've also specified that I want another user. So I've used my colleague Anna and I've given her object ID. And they're my variables that I'm going to input. I've also got locals for my tags, and locals is similar to variables, but it can handle expressions, and it's just for the project that you're working on. So it's built within, and you can merge things together, you can join things together, and it allows you to reuse that value throughout your project. Locals is a great place if you wanted to start putting naming conventions in everywhere. So based on the project that you can connect things in. And that's a great place to have used the word locals. So I'm using it for my tags. So to tagging, I want to tag everything I deploy to make sure that it has my details on it. And then we move on to the resource. The resource is very simple. You just need to give it a name and a location. So there are always minimum criteria that minimal values you need to specify to generate these resources. And then there are additional stuff that we can also add to it. With the resource block, you always get a resource type, and the resource type comes from the documentation. And then you've got the reference name, and the reference name can be anything. It's like a user-friendly name. So that could be resource group, it could have been Joe, it could have been whatever I wanted to do. And there I've just called it RG. And then I've given it a name. And now for my name, I'm using my variables from the above to join to the RG. So it's going to concatenate those together. And I'm also going to use my region. So now I don't have to keep writing this UK South. I can just use that one variable. And then as I go down, I'll look at my data lake. And again, I'll put in the values I want and then the minimum values I need. And one of the key things is here that something like account tier, where I've hard-coded standard. Now that's great if I want to make sure all my departments, all my infrastructure has standard, but that could have also been a variable. So I could have changed that at the time of execution, because I could have, when I execute for dev, it could be standard, but when I do it for prod, it could be premium. So these are kind of things that are driven by the variables that are built. We've got the prefix in there again for the name to make sure that it's consistent. But this time, rather than using a variable, we're just going to call the resource that we generated previously. So we're going to say that we want to use the resource that's been called above, get the ERG, and this time we want to get a property from it, and the property we need is name. So we can do name. You can get most of the properties through this form, but if you need properties that are only available after execution, then you'd need to use a data call, which I'm going to show you further down. So then we've got our storage account, and we know it's going to be a V2, and then we can now start configuring it. So then we can get the resource block for container and start creating the container, put in the minimum criteria we need. The file system, we can get the file system resource, and we resource block, and put the minimum criteria here. And here we can see that we need the ID, so it's now a slightly different parameter property, and we can do that. And oh god, my mouse is gone a bit funny, sorry. And that's basically our data lake. So those three things are the stuff that we said we need to generate: a resource, a storage account, a container, and a file system. And then we're going to start building out our Synapse Workspace. So Synapse Workspace, similar thing. We get the Synapse resources. We put in the minimum criteria. You can see here we've got the file system ID that we need. We've got the password, which isn't very secure, and the password can be generated randomly as well. So you could generate that randomly and then store it in Key Vault, so you never see it. So it's never printed on your desktop. It's never in your GitHub. Or any your Git repositories, and then it goes straight into your Key Vault. And then we've got who we want to be the admin, and the admin I want is the user who's logged in, and that's where that data call comes in. So we're saying, well, we want to get that data call, and then we want you to get the object ID from him, and that's all we've done, is we've basically taken that syntax and we've added the object ID, and we've also got the tenant ID, and that's from the data call that we've been able to get the properties for who's logged in. And now we've also started applying tags to make sure we have the tags of we know who's deployed it. And now we can start configuring it. So the first thing we're going to do is we're going to open up the firewall. It's not great practice to open up all of them. Again, for the purpose of the demo, we'll open up everything. And then we'll start configuring some roles. So to configure the roles, so I want my other user to be a Synapse SQL administrator only, and I can apply that there. Now, what I've done here is I've put a depends on. So I know that I want this to wait. So I want the resource to be created first. So I want the workspace created first. So create that and then do all of the others. Then do this. So I want it to wait for the workspace to be created, the firewall to be created. And so this is my explicitly me defining the dependencies. It might have figured it out, but I want to be sure. So I've explicitly said depends on here. The other thing I've done is I've put a wait statement in here. So I've put wait X seconds. And all wait X seconds is doing is it's basically going to just wait for 30 seconds. And the purpose of that is when the workspace gets generated, because it has all of the moving components, it has the SQL engine, it has the Spark pool to generate, all of that can take a while. And so I just wanted to make sure that it doesn't kick off anything until everything's settled down. So I've just given it a 30-second wait. You don't need to do that, but I just wanted to make sure that everything settles down before we move on. And then we go on to the link services. So now I want to add a link service. So I've generated it. And these are all steps that we would have had to done manually. If we generated a workspace, we would have had to go in, create a link service, we would have had add users. But these are all things we can do automatically through our script, especially if we know that things like users, there's always going to be a user group. We're always going to add, no matter what, all our administrators, there's a user group. You don't want to do that every time. You could do it straight away, so it's part of the process. So with the link service, I need to get a property that hasn't been generated yet. So I need to go and do the get data call. So this is where I've basically said, okay, get my get this data and get this data call. So all of the resource types have a data call, so you can do the data call, and they are in the documentation. So at the bottom of the document, if you go to the bottom, it's actually on the left hand side, they have data calls on them that you can basically you can specify. You can get the syntax. Again, you don't need to know the syntax off the top of your head. You can get the syntax and tweak it. So here I've said this is the name, so I want the name coming from the resource that we've generated, and then the resource group. And this is the value, which is what we needed from that data call. And then, like, again, we put in the minimum criteria. We have some depends on. We're also going to add a permission. So we're going to do a role assignment. So this is to make sure that the Synapse MSI has access. We're also going to generate a Spark pool. So here we've got the Spark pool. We can generate what, we can specify what node we want, how long we want it to be before it terminates. We can add what libraries we want to add to it. So if we've got an ML Ops library that we want to add to all our clusters, then we can. If we've got a specific Spark configuration, you can do all of that. So all of these configurations for your Spark pool can be done. You can also generate your dedicated SQL pool, and you can specify what the size of SKU is going to be. I've got that commented out because I don't want it because it's too expensive. So, but you can specify all that if you want to have a dedicated pool, a Spark pool or SQL pool. And also you've got then the outputs. The outputs is what's going to generate on your command screen, and it's going to say, these are the things that you want to reuse maybe down the line. So you could output the IP address and then reuse that for something else within your project, or just have it output on your screen. So I've output the name of the resource, the location, and ADLS and Synapse. So we can run it now. And to run this one file, we would just generate, we would just use the Terraform command. So the first thing we can see is that there's nothing else in there. So we're going to do a Terraform init. And this first thing Terraform init's going to do is it's going to pull down all of the providers, and it's going to generate, and then it's going to store it here in a temp file. So now I've got my providers that I've asked for, and it's generated the connections for it. It's also locked the file. It's also generated a lock. And then following this, we can now then just do Terraform plan. And here Terraform plan is just going to, it might take a couple of seconds, and then Terraform plan is just going to generate that expectable plan. So basically what it's going to do, so it's going to say to me, am I going to deploy everything? Am I going to deploy a subset of it? And it says it's going to deploy everything. So it's going to have 11 things to add, 0 changes, and nothing to destroy. And then it's also got my outputs here. This is what the naming conventions are going to look like. So it's going to have the words Synapse demo / whatever tags I've given it. And then we can also see what it's about to do. So all of the content in here. So there were things here that we didn't actually specify as part of our Spark pool that we could have. And all of these properties we can apply. And so in the future, if you say, actually, do you know what, I want to change it where my event folder is, then you can specify that as a value inside your Terraform config. Same with that, all of them. So you can see here with with storage account, you've got everything like that. So you can change the type of TLS versions and so on. And you could have specified all of those properties. So now if I do Terraform Apply, it will do the same plan. It will generate the same plan, and then it will basically ask me for, do I want to deploy this, yes or no? There you are. And now at the bottom, it's giving me an option to, do I want to continue? Do I want to approve it? Do I want to deploy all of these? Yes or no? Okay, so I'm going to say no. So we're not going to do this one. And I'm just going to go to DevOps and I'm going to run my pipeline, and then I'll come back and explain what I've done, because it takes about 15 minutes to run. So hopefully I've got 15 minutes left to just go through that.
You have plenty of time, don't worry about it.
Okay. I'm going to stop sharing just so I can go back to sharing the top screen. So everyone see my screen again?
We see your desktop now, yes.
Wonderful.
And now your slide deck.
Yep, wonderful. Okay, so so that was great. We did that all manually, and I did it on my local machine. If I go back, I'll just show. When I did it on my local machine, what I didn't show, I'll get back up, is if it refreshes. No. So what it would have done is in here, it would have stored my state file. So it would have generated the state file and it would have stored it here, but it's not refreshed yet. So it takes a few minutes. But that's what I mean, is it will be stored locally. I'll move that back down. So it's great when you do it manually if you are just a sole person in your organization and nobody else works with you, or you're doing it for demo purposes. It's great, but not when you want to do it and scale it out, because it's very manual. It's, you know, there was so many steps to it. I had to do plans, I had to write manual, I had to actually write them. So there's a lot of manual intervention and manual steps to it, and we don't want to do that when we're in the real world. We also don't want to have explicit permissions. We don't want anyone being able to deploy them. We want to be able to control it, and it's a very key thing when it comes to some of the regulations, is how all these controls are put in place to deploy infrastructure, to ensure that the right person's doing it, the right checks are done. There was no release management process while I was doing it. I was just going off and doing it. There was no CI/CD. What would I do if I had to update it? What kind of version control did I have? I didn't have any. I was just doing it. So all of these taken into consideration, we need to be able to have an approach to deploy it, and that's where Git Ops comes along. So Git Ops is an approach that you can use to deploy Terraform. And it basically means you building repositories, branches, and pull requests to do all of this deployment. So you basically make some changes on a feature branch, for example. You merge that into a dev branch, and then that gets approved. So somebody will then say, okay, does the plan match to what I'm expecting? Yeah, approve, merge it in. And it will also do things like the validate we've got there. So it will validate it, make sure that it's valid. So there's no syntax errors. So, you know, when you go down the line, it falls over. And then it continues through that process. And then once someone's happy with it, it's gone into development and deployed, they'll then approve that to go into the test environment. And then that gets deployed into test, and then it goes through the same thing. You have CI and CD pipelines that somebody will approve the plan, and then that plan is what's applied. So you don't apply, with apply, you can apply a specific plan. You don't have to run a plan during the apply. So we want to run a plan. We want to get that approved, and then we want to apply that approved plan. And so you do that in test, and then you get that signed off. Everyone loves it, and then you put it into production, and you do the same step. you generate a plan, and then someone approves that plan and they're happy with that plan, then that plan is approved and applied. And that's an approach within development for Terraform that you can use. There are various tools out there. So you've got DevOps, you've got GitHub Actions, you've got Jenkins, and so on, that allow you to build CI/CD pipelines. And we're focusing on Azure because, well, let's be honest, we're looking at Microsoft stuff, so it's going to be DevOps. But DevOps, Azure DevOps also has other components that you can do. So it's more than just a release tool. It also does the whole things with backlogs, wiki. It does the Git repository. So there's a lot more you can do with DevOps. So DevOps handles YAML pipelines, and to build that YAML pipeline, you need to have a pipeline. And within that pipeline, you basically specify some stages, and stages can be things like the different environments you want to deploy. Within the stages, you have a job. You can have multiple jobs, and they can be dependent on each other. And then within those jobs, you'll have some steps, and within those steps, you'll have tasks or actions or scripts. So things like install a component, call a REST API, connect to the key vault, build me some artifacts. So it does all of those different tasks. So how do we do this in Terraform? So in Terraform, the example we're going to look at is basically going to build a pipeline. And at that top level, we're going to have some triggers. So we're going to say, at what point do we want this pipeline to run? Do we want it to run when it merges into a specific branch? Do we want it to be done manually? We're also going to specify a pool. Do we want it to use a self-hosted pool? Do we want to use Microsoft's agent or our own agent? We're going to specify what type of parameters we want to enter. So do we want to enter what the environment is going to be, or what the name of the project will be? Do we also want a variables in there? So do we want static variables, dynamic variables? Do we also want variables that are going to come through the key vault or come through a variable group? And then we will specify the stage we want to deploy. We want to deploy a development stage, and there'll be a couple of jobs in there, and there'll be one job in there. Within that job, there'll be one step, and within that one step, there'll be multiple tasks. And that task will be to go and get a key vault to install Terraform. So we need to make sure Terraform is installed on our machine. So we can't do it if it's not installed on our machine. We're also then going to do the init, we'll do the validate, we'll do a plan, and it will then do an apply. Now, a good practice is between plan and apply. I was mentioning that you would have a gate, which would basically say, does that plan look right? Yes, approve it. And that's a step that you have to build within that. For my demo, I don't have that step, but it is a good practice to do it. And then you just repeat for each environment. Then your next stage will be, once you've approved your stage, development stage, you approve that, and then you go to the next stage, and it'll go through the whole process again, and then you approve it, you apply it, and then you approve, and then it goes to the next environment, and then it goes through. And that's the process that you follow. Oh. Hello?
Yeah.
Oh, my PowerPoint has crashed.
Okay.
Oh, let's reopen it. There. All right, so let's get through all of these. There you are. Next one, just before we go to the demo. Okay, so the other thing we need to make sure is that Terraform extension is added, and this is done at the organization level. DevLabs is the recommended one by Microsoft, and we need this, and this will basically allow us not to have write CLI commands within our Terraform within our YAML script. So the demo we're going to look at a configuration file. Then we'll have a look at the YAML file, which will show where we retrieve some credentials, and then we'll deploy using the Terraform steps. And then we'll also have a look at where the Terraform file is stored. Can you still see my screen?
It just went black.
Try again. Okay. So
we've got your desktop and your browser. Yep.
Yeah. Okay. So let's have a look at the code first. Okay. So earlier we looked at the demo one. So now we're going to have a look at the DevOps one. So with the DevOps one, I've taken the same script, but what I've done this time around is we've broken it down. So taking the main script, and it was quite a long script we saw, and I've broken it down into some of the core components. So data, output, variables, providers, they've all been broken down into their own file. And then the main file has stayed to keep all the resources. And now that's quite a good practice because you want to break it down so it's easier to manage, clear to read, and you can keep all your variables together, keep all your data calls together. And we can see here with the data that it's got my simple data call that I was made. My outputs had my outputs, the values that were on the bottom. And then the main, nothing's changed. So I've got my resource, my lake, my Synapse, the configuration for the Synapse, my link service. So nothing's changed here. So all of it's still the same. Okay. So nothing's changed on those files. What has changed are these two. So the provider file. So now, because I'm going to use DevOps, and DevOps is a machine, is going to use a machine that could be my self-hosted one, or it could be a machine that's Azure. And if it is the Azure one, then when I generate the state file, it's going to store on that machine, but then the machine will be gone, and then I'll lose my state file. So I need to specify somewhere that I'm going to store it. So a back-end remote location. And so for that, I'm going to use the Terraform backend block to specify where I want to store it. So here I've said, okay, this is the container I want you to put it in, the storage account, the resource group, the ID I want subscription ID that I want you to use, and also what I want you to call it. So I want you to call it that. So this is the name, and this is what I want you to retrieve, and this is where I want also I'd like to store it. But this is where I'm going to call it, and I want you to retrieve that backend. I'm also going to log in this time as my service principal. So as was mentioned, we need a service principal because we don't use my logins. I don't want to have the permissions. So this time, as part of the configuration for Azure, I'm going to use my service principal. That service principal is going to be stored in my key vault. So I'm going to put some variables in here to say for the client ID, it's this variable. And so those variables have now been added. And they're the stuff I'm going to provide at the time of execution. So within my YAML, I'm going to get them and I'm going to provide them within the Terraform project. So now I've got some new variables. Okay, so my service connection and my backend. And also at the top, what I've now decided to do is I've decided to remove those defaults. I don't want those defaults because I want to be able to reuse this project. And I want to be able to reuse the project, and I want to be able to have multiple variables provided. So this time around, I've put all my variables into a .tf vars file. And this .tf vars file has the prefix that I want to use, has the and other connection information that I want to use. It would hold all of those values. So the actual values for my variables are now in there. And I could have multiple of these .tf vars files, one for dev, one for test, and one for prod, and they could all be configured slightly differently. So, we mentioned earlier, your dev could have standard and the production could have premium. So we could specify those in these different .vars files. Then we've got our YAML file, which is quite a long YAML file. Mentioned about triggers. There's not going to be any triggers. We don't need any. We got some. We've got a pool, so I'm just going to use the standard Microsoft one. And then I'm going to use, I'm going to then have parameters. My parameter is going to be the value I want to put in. So the name of the prefix, and that's going to be a parameter. Also the environment I want to use, and that's going to be the parameter. And then they're going to be part of my variables. So they're going to come in to my variable section, so I can reuse it within the project. And within the environment, it's going to be just looking at the parameter value that I've passed in. For the directories, where my folder is structured in the Git repository, and that's just a file location I want to put in, the latest version of Terraform, and that could be, again, a variable value. All of these values here, these variables, are hard-coded. They could have been values coming from Key Vault or values coming from a variable group that could be constantly changed. They've been hard-coded here, and then we can see that this variable is dynamic. So it's going to use, to generate my key name, it's going to use basically the environment and the prefix to generate that state file name. And then following that, we've got the different stages, the job. So I've only got one stage here, I've only got one job here, and then I've got, in my job, I've got multiple steps. So one step is to check out the repository. Next step is to go and get my key, retrieve my values from Key Vault. So you can see I can get my client ID, secret, tenant ID, subscription, all from my Key Vault using this service connection. So the service connection is the connection you have in DevOps. It's the connection that DevOps has permissions to your Azure account and the resources. Then it's going to install my extension. So again, I've said what the task is. I want to make sure that the command that the value I'm passing in, and following that, then we'll get to the core parts of the code. So as before, we want to do a command. So we don't need to now type in the word Terraform in it. We just can say use the command in it. We specify where the folder is, what does it need to initialize? Where's that folder that it's looking at? What Terraform project is it looking at? Because it needs to find that provider block. And also the values that we need to pass into it. So these are the values we want to pass in for the backend config. So where is it going to store it? And then it's looking at the environment, the connection, the credentials of the person who's logged in. For init, for validate, we've basically just entered just to validate, and we don't need to put any backend information because all it's looking at is that directory to make sure that the configuration file is valid, that everything's in there is okay. The reason we have valid as separately, because plan does the valid, the reason we have it separately is just to make sure that we identify those errors quickly. So we're not waiting until we're halfway through the plan and then suddenly we identify that there's an error. Then plan is slightly different. So plan has the same thing. You've got the command and you've got the connection and you've got the location. But then we've got some command options. And in this command options, we're now specifying the vars. So at the time of execution of that plan, as mentioned, at the time of execution, we're going to pass the variables. So we've got all of these variables we're passing through. So we've got the client ID, we've got the backend information, and we've also got the tf.vars file. So these are the vars for the actual configuration file, where the others are to make sure we're connected, make sure we know where we're storing it, and then we're also going to output it into .tf plan. And in between these two steps, this is where we would have that approval process, because that plan has been generated and someone should approve that plan before it is applied. And then with the Terraform Apply, we have a command here to say auto approve that plan. So we're approving the plan that's below, and the auto approve makes sure that we don't get that prompt to say, do you want to approve or not? And the reason we don't want that is because with DevOps won't allow us to say yes and no in the command screen. And then once we've checked all of that in, we can run the pipeline. And now the pipeline didn't work, or partly worked. It's timed out, but it's partly worked. So I ran this because it takes a while to run. But if you ran a new one, we can see here we've got what branch we want to use. So I do have a branch where when things go wrong, and then we've got a project name, and we've got the dev. So they're the parameters that we defined in our YAML, and it's in there. And then when you run it, it's going through the steps. So it's gone through the steps of checking out the repository file, retrieving the keys, doing installing so you can see that it's retrieved the keys, it's installing the Terraform, doing the init, doing the validate, doing a plan. So here we can see the plan at the bottom. It should be 11 again. Yeah, and these are what it's going to be called. And then it's doing an apply. And we can now see that it's giving us the same type of message it was earlier as it's going down. So is it creating, it's creating, it's creating, it's complete. So we can actually see it's completed a lot of the things, but when it got to the Spark pool, it decided to fall over. So here, if we went to the resource, and we can refresh, and we can see that it's generated. If we went to the ADLS one, we can see that there's a container there called main, which is what we wanted to create. It automatically creates the file system. We can see that we have the tags that we defined, and we didn't do much else in this storage, but we did do a few more things in Synapse. And because the other bit failed, it fell over. So it's not added. I don't think it's added the connections. No. So this is why we have the one that I pre-built. So here's one I made earlier, which used the same file but just a different name. And we would have expected to see this. So we would have expected to see our additional user who has been added as a SQL administrator. We would have also seen a link service created, but the link service also has the permissions already. So you would be able to do a test connection and connect straight away. So these are steps that you would have had to do manually. You would have had to create a connection string. You would have had to create integration runtimes, or add Git repositories to it. So all of these configurations we could have configured where we want it to be stored, where the Git repository is stored. We've got obviously all the users. We could have had multiple users. It automatically added the service principals. We could have also loaded up some notebooks if we wanted to, or connections straight away. So if I go back a step, see, and we can see here that it did try to create it, but it fell over, and so it didn't create my connection. It didn't create my user. Yeah, it didn't give me my access to. It didn't give me permissions. And then here we've also got things like the tags that we applied, and you get everything. So it is all there. Next, we specify that we wanted to store the state file. And we can see here there's the state file been stored. So it's got the naming convention I wanted, synapse devops.dev, and there's the file which was generated at 9:58, so a little while ago. So it's now generated that state file, and that's how we would deploy it using DevOps, but when it ran successfully. You can see I did this yesterday's demo, and it was successful. And it successfully ran, and at the end it will tell us how much what it's done. So it says at the end it goes applied, resources created, and then it would have said, and then it's basically got your outputs of this is what I've generated. Okay. I'm just going to switch back to my PowerPoint. Okay. So that was the demo for that. So hopefully you can see the screen again. And we'll just do a quick recap of questions. So we ran through deploying infrastructure, cloud infrastructure, and we just did that probably about 20 minutes. In 20 minutes, you could have done it if it worked, but it's quick and fast. And it's efficient. So that's what I'm trying to kind of say. So I built a manual one, and then I split the manual one to be a bit more better practice, and then deployed it using DevOps, and all of that was able to do by just taking chunks of the initial manual one that I generated. So it's great to create it locally if you're doing it for a POC. But then if you want to publish it and use it more collaboratively, you need to put it into DevOps. We saw that the Terraform language was easy to read. It was easy to maintain. We could see where there was issues straight away, and it was it's declarative language, so it means it is explicit. So what you're going to see is what you're going to get. It was easily repeatable. So as I said, I was able to take something and copy it and reuse it, and then you can reuse it multiple times for different environments. We could use that same configuration for dev, test, prod, but add different variables to make sure that our clusters or our storage account is a different SKU. It also makes it consistent. So we kind of saw that because I've deployed it twice, I can have the same thing, one as a test and one as a dev, and so on. Also, no matter how many times, if I run that code again, it will. If I run DevOps again, it probably run successfully because it won't generate everything again. It won't remove the Synapse Workspace. Instead, it will identify what it needs to generate, and then it will run that, and then it will basically just update or create the additional resources it needs. We saw DevOps using the continuous. We use DevOps to do continuous deployment. And this is to remove the unnecessary permissions, the explicit permissions. We don't need to give them. We also don't have to do it manually, and we remove that manual step. We wrote some YAML, which had pipeline stages, and this is a good way to build out your CI/CD pipelines. And then there was the governance. So we need to make sure all of this is governed. There's loads of gating in place. There's gating in between plan and apply to make sure that we're building the right resources and we're not removing anything, and that needs to be approved. And then we're making sure that it gets approved before it goes into the next environment, and so on and so on. Git approach. We looked at Git Ops approach, which uses repositories, branches, and enforces things like pull requests, and that will help you keep those controls in place. Now, give it all a go using Terraform to deploy Synapse or any other resources within the Azure, or even use it for AWS and Google Cloud. Use DevOps or use another tool within DevOps, within Git Actions. Use Git Actions, very similar to DevOps, and give it a go. It really does make deploying your infrastructure quickly. And that's the end. So thank you for listening. I'm not sure how long that was in total, but if there's any questions, I will get the slides and stuff up on my GitHub, and that's my details.